Greetings to dear students. Okay, let us continue the problems to find the residue of the given function at the point. Okay, so here we have problem number 7. Use Lorentz series to find the residue of e power 2z by z minus 1 the whole square at the point z equal to 1. Okay, so they are asked to find the residue of the given function at the point 1 by using Lorentz series. Okay, we should not use the fourth formulas here. Using Lorentz series only, we are going to find the residue of the given function at the point 1. So using Lorentz series means what? It's a definition, the coefficient of 1 by z minus 1 in the Lorentz series expansion, which is the residue of f of z at the point 1. So first we let us expand the given function about the point z equal to 1. So about the point z equal to 1 means the function should be, the z should be in the form z minus 1. Okay, so let take f given function as f of z. Since the denominator part already have in the form z minus 1, we don't need to apply any works there. Okay, if it is not z minus 1 means, then we have to make it as z minus 1, but already it is in the form z minus 1 only, so we don't need to apply any work there. So we are going to consider it in the numerator part only. In the numerator part we have z only, so we have to make it as z minus 1. So for that, what we are doing is we are adding and subtract 1. Okay, we are adding and subtract 1. So we get e power 2 into z minus 1 plus 1. So take z minus 1 as one term. Okay, z minus 1 as one term plus 1 as another term. So we get e power 2 into z minus 1. Okay, this is equal to e power 2 into z minus 1 plus 2. So e power m plus n, which is equal to e power n into e power n. So this is what I have written here. E power 2 into z minus 1 into e square. Okay, divided by z minus 1 the whole square. So now what we are going to do is we are giving the expansion of e power z here. Here instead of z we have 2 into z minus 1. So in the expansion of e power z, in the place z, we are replacing z by 2 into z minus 1. Okay. So e square by z minus 1 the whole square into 1 plus z by 1 factorial. Here z as 2 into z minus 1. So 2 into z minus 1 by 1 factorial. The second term z square by 2 factorial. So 2 into z minus 1 the whole square by 2 factorial and so on. Now we are multiplying the bracket term by e square by z minus 1 the whole square. We get the first term is e square by z minus 1 the whole square. Okay, the first term is e square by z minus 1 the whole square. The second term will be 1 z minus 1 will get cancelled. So 2 e square divided by z minus 1. In the third term, z minus 1 the whole square, z minus 1 the whole square will get cancelled. So which implies 2 into these. Yeah, here we have 2 square. Okay, so it means 4. So 4 by 2, 2. So 2 e square and so on. Okay, so this is the expansion, Lorentz series expansion for the given function. Now we are going to now we can find the residue of the function f of z. What is residue of the function at the point 1? It's a coefficient of 1 by z minus 1 in the Lorentz series expansion. So what is the coefficient of 1 by z minus 1? 2 e square. So this is the residue of f of z at the point 1. Okay. So here we didn't apply any formulas. Only we expand the given function about the point z equal to 1, and then we find the coefficient of 1 by z minus 1, which is the residue of the given function at the point z equal to 1. Okay. So next problem. Find the residue of z e power z by z minus 1 the whole cube at its pole. Okay. So we are going to find the residue of the given function at its poles. Note that this function has only one pole. What is the pole? 1. 1 is a pole of order 3. Okay, 1 is a pole of order 3. So we go with the formula 4. So the residue of f of z at the point 1 is, since the pole of order 3, we have to differentiate 2 times. So g double dash of 1 by 2 factorial, where g of z is what? In the denominator, we have only this one. So g of z will be z into e power z. So now we need the value of g double dash of 1. So for that we are going to differentiate the function g of z as twice. So first, when we differentiate, since these two terms contain the variable z, we are going with the uv method. By uv method, we have z into e power z into differentiation of e power z. Differentiation of e power z is e power z plus e power z into differentiation of z. Differentiation of z is 1. So z into e power z plus e power z. This is the one-time differentiation. Again, when we differentiate, we get z into e power z will become z into e power z plus e power z plus e power z. Differentiation of e power z is e power z. So therefore, g double dash of z is this. Now you substitute the value 1 here. G double dash of 1 is equal to 1 into e power 1 plus e power 1 plus e power 1, which is equal to 3 times e. So we have found the value this. So therefore, residue of f of z at the point 1 is the value of this that is 3e by 2 factorial, that is 2. Okay. So I hope the two problems will be clear to you. We have only one problem left in the section. We will see this in the next video. Okay. So thank you, dear students. If you have any doubt, kindly ask me. Okay. Thank you.